In this video, we're going to learn about how to find the magnitude of a vector. But first of all, what is the magnitude? Well, the magnitude of a vector is simply the length of the vector. Remember, we think of vectors kind of like arrows. So when we find the length of the arrow, we have found the magnitude of the vector. Now, to actually do this calculation, let's assume that you are given a vector v, which equals AB. So the horizontal component's A, the vertical component's B. Then you're going to use the formula, the magnitude of V equals the square root of A squared plus B squared. Notice here that you have the bars around V. That means the magnitude. That's the notation for that. Now, why does this formula work? I get that question a lot. Well, here's the deal. When I look at the vector V, it has the horizontal component A, the vertical component B. What does this look like to you? Hopefully you think it looks kind of like a right triangle, because then we can think of this like Pythagorean's theorem. So A squared plus B squared equals C squared, where C is the length of vector V. It's the hypotenuse of this triangle we've drawn. Now, to figure out what the length of V is, we're going to really solve for C here. So we're going to take the square root of both sides, and we'll replace C with the magnitude of V. Oh, look at that. That's that formula we saw just a minute ago. Let's see if we can put this into practice. Let's say I want to find the magnitude of the vector V equals 3, 4. Well, I can see that my A is 3 and my B is 4 because that's my horizontal and vertical components. So now I can plug them into the formula. Magnitude of V is the square root of A squared plus B squared. So in this case, I'm going to have the square root of 3 squared plus 4 squared. And 3 squared is 9, 4 squared is 16. I add those together, I'll get 25. And the square root of 25, I happen to know, is 5. So I can see the magnitude of the vector 3, 4 is 5. And that's what you need to know about vector magnitudes.